Okay, so here's the last of chapter 6, and we are looking at the challenge questions. All right. So we are given an equation which is x minus 5 squared plus y minus 3 squared, and that equals 20. And it has a center of A. Okay, so presumably then A must be 5 and 3. And then we are given, and it intersects with another circle, which is x minus 10 squared plus y minus 8 squared equals 10. And it has a center B, so presumably B then is 10, 8. Okay. And it intersects at P and Q. Okay, and they have given us a diagram in the book. Find the equation of the line connecting P and Q in the form ax plus by plus c. So we've got something that looks a bit like this. We have got 5, 3. There's 5, there's 10. 3, 6, 6, 9. Okay. 3, 6, 9 up that way. 5, 10 this way. So we've got 5, 3 here, and it's the 20 is the square root of 20 for the radius of the circle. Square root of 20 is somewhere in the region of 4.5. So the circle is 4.5. So circle sort of comes around here like this. Then we've got the other circle, which is, that's a 10, 8, which is about here, and it's on square root 10, which is 3. So that gets us back to about 7, so it comes around, and it's something like that. Okay, that's a terrible circle, but anyway, doesn't really matter. Okay, and we've got P at the top and Q at the bottom. The first thing we want to do is find the equation of the line connecting P and Q. Okay, so we know that the slope of that line, okay, so we can find the slope of that line quite easily. What we need then is a point on that line. So if we want PQ, we can do it with either finding radius lengths, which we know are square root 20, square root 10, finding the middle over that bit, getting that point in the middle that's on the line AB, and then taking inverse sines of that. But I think, given the fact that part B wants us to find P and Q anyway, I think that that's what we're going to start by doing. I'm going to take this and I'm going to multiply it out, and I'm going to get x squared minus 10x plus 25 plus y squared minus 6y plus 9. Then I'm going to do minus 20, and that will equal 0. At the same point, I'm going to take this equation, the x minus 10, y minus 8 equation, I'm going to multiply that out to give me x squared minus 20x plus 100 plus y squared minus 16y plus 64 and minus 10 to make that equal to 0 as well. As I start simplifying this down, okay, my x squareds on both sides will cancel, my y squareds on both sides will cancel. Okay, on the left hand side I've got minus 10x and that, and a minus 20x on this side. So when I bring it across, it'll be a plus 20x, meaning I've only got 10x. Okay, so that's this one dealt with, this one dealt with, This one dealt with that done, and that done. Okay, now let's do the y's. Okay, that's going to be equal to, so I've got minus 16y and I've got minus 6y. When I bring it across, it'll be a plus 6, giving me 10y. Okay, so 10y, so that is that one and that one dealt with. And then I've got a 25 plus 9, 25 plus 9 minus 20. Okay, that gives me plus 14. That's those ones. That's everything on that side. And on this side, I've got 164. 164. Take away the 10, which is 154 plus 154. Okay. So that's where both of them are equal to. So let's see what we can do with that in terms of what we can get out, because we have two equations, two unknowns. I'll just put them together. So we end up with, okay, so the 10y minus 10y there. So to finish that off, 154, let's put it into the equation of 10x plus 10y minus 154 minus 14, 140, so minus 140 equals 0. Okay, is the equation of PQ. Okay. Now we need to find the actual coordinates of PQ. So we need to put one of them equal to one of these equations, and it should give us two answers, which will be PQ. Okay, so I'm going to go to the bottom one. So we end up with 10x plus 10y minus 140 is equal to, and I'll take this right hand side here, x squared minus 20x plus y squared minus 16y plus 154. Okay, and we need to find a solution to that. Doesn't look very promising, but we'll see what comes out. Okay, so one equals the other. So the x squareds, let's take x squared over here minus x squared, we'll bring that across, plus 30x equal to, let's bring the y squared is still there, and we've got minus 16, now we've got minus 10, so minus 26y, and then we can put it all together, 140 plus 294. Right, let's have another look. In hindsight, this is a silly way of doing it. What I should really do is take this equation of PQ and say, right, x is equal to 140 minus 10y all divided by 10. So we end up with x is equal to 14 minus y. At this point, I should take one of the equations of the circle and I should substitute this value of x into it, 14 minus y. So let's start with the one that we had already started with, 14 minus y minus 10 squared plus y minus 8 squared equals 10. Okay, 14 minus 10 is 4, so we've got y minus y plus 4. Okay, squaring that out gives us y squared minus 8y plus 16 plus y squared minus 16y plus 64, and I'll put the minus 10 here and make it equal to 0. 2y squared, 16 and 8 minus 24y, 16, 64, take away 10, 16 plus 64, 80, take away 10, 70 equals 0, and then we can say y is equal to using a solver. Minus 24 and 70, and we get 7 and we get 5. With that done, we can put 7 and 5 into here. I'm going to say x is equal to 14 minus 7, meaning it is equal to 7, and x is equal to 14 minus 5, which is equal to 9. So we get our points of 7, 7, and we get a point of 9, 5. Looking at the diagram, 7, 7, 9, 5, 7, 7 is the P, and this one is Q. Okay, delightful. Last part of it, find the area of a kite. Okay, so area of a kite. All right. So area of a kite is the two diagonals, well, corner to corners, call them P and Q. No, not P and Q, we've used them. Okay, but if your kite is here and you've got lengths of A and B, it's A times B divided by 2. So we need the length of PQ and we need the length of AB. Okay, so length PQ is equal to the square root of 7, 8, 9, that's 2. 2 squared, 7, down to 5 is 2 again, plus 2 squared. Which is the square root of 8 will do for now. Then we've got the length of AB, and if you remember the length of AB, so from 5 to 10 that's 5, 3 to 8 is also 5. So we have the square root 5 squared plus 5 squared, which is equal to square root of 5 squared plus 5 squared. It's going to be which is 5 root 2. This one is 2 root 2. So 5 root 2. So the area is equal to all divided by 2. Units squared.